Okay, so this is the first of probably 7 days of notes for Chapter 8. And after that, we have 2 days of review and a test, and we're done with Chapter 8. Then we have 3 days of Chapter 6, a day of review and a quiz for Chapter 6, and we're done with Chapter 6. And then that remainder is this you guys prepping for your final. And every day is just going to be, I'm going to have the answers online. You guys will have it. I will give you the first 4 packets of the final review. And people are like, whoa! It's by chapter. Chapter 1 and 2, 2 and 3, and Chapter 4 and 5 you'll get before Memorial Day weekend. And I'll do that because if Memorial Day weekend is really cold and rainy, it's kind of a nice thing to use and get done. If it's really nice, I understand, but I also have days to get it done. But if you're able to probably plan your time a little bit better, your improvement of your understanding of the total year is covered. And remember, it is over the entire year, this final. Because this is a semester course, the entire year that we taught you is done in 18 weeks. Okay, they just cut out a few of the practice problems. They go way faster, and you have maybe 5 tests, maybe 4, and that's it. Okay, so keep that in mind. We softened the blow on most of the stuff the way it was, but Chapter 8 is all about formulas. If you know the formula, you know the relationship, you're totally golden. So let's get this going. We're talking about conic sections and parabolas in 8.1. 8.2 is ellipses, and 8.3 is going to be hyperbolas. Okay, you guys work with this stuff every day. You just don't know it. If you ever look at a cell tower or anything, these kind of curved antennas are the things that we're working with. Now, this first page has got a lot of history on it. I'm going to take it that as you go through, you're able to read on your own. I'm not going to read it for you at this time. What I want you to keep in mind is that some of the history of this. It's not something that's been new. It's been around for a long time. And the conics allowed us actually to have Newton Leibniz develop calculus. Okay, so the idea of being able to go from algebra to geometry, geometry to algebra, was our argument for calculus going through. Now, if we ever get to go on to our next page, 8.1, let's talk about where we're going. We'll be able to understand how conic sections are formed, understand the geometry of parabolas and their key features, write equations of parabolas, and translate a parabola. Okay, we're going to be translating around the axis. We're not going to be doing that today. We'll be doing that on Monday. But we're going to write equations for parabolas as we go. But before we get there, I want you to see what a conic is. And really what happens if I took a segment and I restricted its movement right here, and I just kind of mixed it around like a stirring stick, and this was its pivot point. If that's the pivot point, that stirring stick goes all the way around, and it makes the 2 different napes. That's what this is called. Notice the V divides the things in what is called napes, and that's what they're called. Okay. Now, this idea of a cone that's created, cones can be, wider. Okay, can even be narrower as we go, but you want to keep in mind. It's conics. It's the cross-section of a cone that makes an ellipse. It's the cross-section of a cone that makes a circle. It's the cross-section of a cone that makes a hyperbola, parabola. Okay? It's where those things are. So as we're stepping through, some atypical conics, known as degenerate conic sections, are shown below, and my meaning below is in the next page of our packet. Because of its atypical and lacks some of the features usually associated with an ellipse, the circle is considered to be a degenerate ellipse, okay, because it has that 1 center versus the 2 that we're going to be working with. Other degenerate conic sections can be obtained from the cross sections of degenerate cones, such as cones occur. Such cones occur when the generator and the axis of the cone are parallel to the perpendicular axis. So parallel to the axis, I'm talking about circles. Parallel to the axis, I'm talking about hyperbolas. And perpendicular axis up and talk about circles when I'm going. So this is what we're talking about. Ellipse is skew. It's not perpendicular. An ellipse is not perpendicular, but it's definitely not parallel. And it will be, I should say, it'll go parallel to the edges of your cone, because as soon as it goes beyond parallel to the edges, it's cutting into two different cones like it would for a hyperbola. But a hyperbola is parallel to the axis. Okay, an ellipse is just not perpendicular, and between these two lines, it's going to run between the two. I should say it this way. So when we're talking about an ellipse, it's not perpendicular to this axis, and it's not parallel to the side of the cone. It's between those two angles, and that will make your ellipse, as we're working through it, the different sides of the ellipse. A parabola is made, this plane that cuts it, that was interesting, this plane that cuts the parabola is actually parallel to the side of the other cone, so it doesn't cut into the other cone. A hyperbola will cut into the cone, so it's plane that makes it, the idea of it is parallel with the axis. And then if I have a cone that goes through that point, that's fixed point, that makes the two cones, it's just going to be a point as we go through. And if I lay it right on the edges of the sides of the cone, they're saying you can make yourself an oblique line, so we got ourselves a line. And the intersecting faces as we go here, that intersecting lines, if it's right down the axis, the cone is cutting right down the axis, this is actually a line that's interfacing, so they're talking about intersecting lines, and that's how they're defining them, okay, using the cones. So we got the three standard types of conic sections, and the three degenerate conic sections, and these are the bottom three are the degenerates, and the top are the standards. But the conic sections are defined algebraically as the graphs of second-degree quadratic equations in two variables. That's something you're filling in, where A, B, and C are not all zero. Now, we will be completing the square. We will be taking a formula like this and completing square. We won't be doing it for our parabolas today, but we will be completing the square. It's kind of a cool process to actually split it up. Now, a lot of information is coming to you today. Make sure you know it's a lot of vocabulary. It's very geometry centered. Because of the vocabulary, because of the shapes, you got to make sure you connect what everything is because of the terms. Because you're going to be given information, you're going to be given the directrix, you're going to be given the length, you're going to be given the width, and when we do that, you got to know what they are. So as I give them to you, you go, oh, I know exactly where that would be in the parabola. Okay, so as we go through, we're going to point them out. Definition of parabola. Parabola is a set of all points in a plane equidistant from a particular line called the directrix, okay, and a particular point called the focus, okay, and that point between the focus and the directrix, that perpendicular line, the axis of your parabola, halfway between there is your vertex. Okay, the line passing through the focus and the perpendicular directrix is the focal axis of the parabola. The axis is the line of symmetry for the parabola. The point where the parabola intersects its axis is the vertex of the parabola. The vertex is located midway between the focus and the directrix and is the point of the parabola that is closest to both the focus and the directrix. And here's a property that's in with this. The distance from each point on the parabola to both the focus, so any point, so from this point or any other point, the distance to the focus and the distance, perpendicular distance to the directrix is always the same. Okay, that's how this parabola is created. Okay, so if I decided to go another point way out here, the distance from the focus to that point is the same as the distance from that point back to the directrix, and that's the perpendicular distance. Those will always be the same. That's how it's defined, okay, as we go around. Now, you have your vertex, You have your directrix coming across here, and we're talking about that distance as we're talking, and that axis goes right through the vertex perpendicular to the directrix. We are going to be working with parabolas that open up, open down, open left, and open right. Okay? So we're simplifying our process. We're not going to have them skewed. Now, standard form of parabola that opens up. Okay, the standard form of parabola that opens up is x squared equal 4py. Okay. Now, in that, I have my directrix line coming across here. I have my focal width. The focal width is the distance across my focus. Okay, the focal width is the distance across my focus to each side of the parabola. This is called what we'll call a chord. And remember, when we have a chord of a circle, the endpoints are on the circle. Okay, the focal width is a chord whose endpoints are on the parabola, and it goes through the focus, and the focus is the midpoint because that splits it up. Okay, that helps us actually graph the parabola. Now, also, if I'm looking at the focal length tells me how far the focus is away from the vertex. So if I tell you the focal length is 4, it's 4 units in the positive direction from the vertex, okay, 4 units to the focus from the vertex. If I tell you that the focal length is -4, then we go from the vertex down 4, and that's where the focus is going to be located down here, as it is in my B picture here for x squared plus 4py. Now, there are a lot of patterns with this, so don't feel like overwhelmed and lost, and yes, we'll memorize these, okay? But it's all about the pattern that you're going to see. When you have x squared equal 4py, remember, a regular parabola is y equal x squared, right? It's either up or it's down. Okay, so you know it opens up or it opens down based on the sign, whether it's positive or negative. Okay, but y equals x squared is up and down. Okay, and I know it's reversed, but that's considered the standard form for a parabola. When I'm going left or right, it's y squared equal x times 4p. And you're like, well, and my focal length is still the same direction from the vertex. It just tells me if I'm going to go from the vertex to the right or vertex to the left, and wherever my focus is, my directrix is opposite it. Okay, and my vertex is halfway between the two. Now there is a table that will help us keep this stuff straight, but after your first like 3 or 4 times that you've graphed them, you start memorizing where everything is. And it makes sense. We name these things based on, their parts. So make sure you know what the name is, what the part is, and you're able to find it if I put it in a word problem. So here it is. Focal length is p. The directed distance from the vertex to the focus, directed distance. So if it's positive, it's going to the right or up. If it's negative, it's going to the left or down. Okay. The chord, a line segment that with endpoints on a parabola. And the chord we will work with the most is the focal width. The focal width is our chord we're going to work with the most. Our focal width is the absolute value of 4p. Well, we saw 4p, x squared equals 4py, or y squared equals 4px. That's the focal width. Okay, that's telling you how wide the parabola is through the focus at that point. And it's a chord. It's going to be parallel to the directrix. Okay. Now, we're going to be working today with parabolas at the vertex, just to learn how to do them, to kind of start crawling today. Okay, we'll start running a little bit more on Monday. But the standard equation, x squared equals y. Remember, this is open upward or downward. Everything on this column is for open upward or downward. It's according, the focus changes because it's open upward or downward. The directrix is y equal because that's a horizontal line, okay? Because of open upward or downward, the directrix is, horizontal as we go through. If it's open left or right, the directrix is vertical, so it'll be x equal. Focal length is p. The axis of the parabola is the y-axis. The y-axis will be splitting it right in half. Okay. Focal width is the distance across the parabola. It's a chord. Okay. And we're going to be working with those as we do this today. Now, if it's this one, this column fits everything else as we go through. If it's open right or left, if it's y squared equal 4px. P0. It's been adjusted for the focus. Okay, it's P0 because of the way it's open. Directrix is x equal negative p. Okay, it's reverse direction, and we'll talk about that. I don't necessarily memorize the directrix stuff. I just know that when I graph the parabola, certain pieces are at certain spots opposite each other. Okay, I do remember that if it's x squared equal 4py, it's open up or down. And then if it's y squared equal 4py, it's open left or right. And from there, I adjust everything else. So hopefully you'll see that it's just, I kind of group them and chunk it that way, and everything else comes in because I know what the focal length is, I know what the directrix is, I know what our focus is as we go through. So let's talk about this as we go. The first thing, I'm going to try to refer back to this every time. So we're going to be there. Sorry about keeping it down, so that way you know what I'm talking about, where I'm going with it. Okay, finding the focus and directrix, okay, and focal width of this parabola. Now, find the focus, directrix, and focal width of the parabola. Y equal negative 1/3 x squared, okay. Now, first of all, I want to put it in that standard form of parabola that we've been working with in the table above, okay. So I'm just going to flip-flop this. This is negative 1/3 x squared equals y. I'm going to multiply by negative 3 for both sides. So I clear it out so I have x squared all by itself. Okay, are you okay with what I did to get there? Right now, I know that it's x squared equal 4py. Okay, so it's going to be open up or down. And because of that negative, it's going to be open down. Does that make sense? Okay, so okay, and it's because this value is negative. Now, let's talk about that value. My focal width, I'm just going to grab it right away. My focal width, with this absolute value of 4p, is equal to negative 3. Okay, are you all right with this so far? Well, the absolute value shouldn't be negative 3, but it's going to be 3. I should say it's 3. But I want to solve that, so I'm going to sneak up a little bit. I want to solve that, so I know 4p is equal to negative 3. Okay? Are you all right with that? That 4p outside of the absolute values would be negative 3. Because x squared equals 4py. So I'm going to solve for p. What p does, go look it up. What's p? Specifically, if I go look it up. So I look up there, focal length. Well, what's the focal length? If it's open down, keep in mind, generally my parabola is going to look something like this. If I got this going on here, I'm going to have this doing this. My parabola is going to be open down. It has a focal length. And what's the focal length supposed to do? Look above on the top part of the page. I'm going to have you look it up again. Okay, what's the focal length supposed to do? My focal length, p, the directed distance from the vertex. Okay, well, gosh, the directed distance from the vertex, okay, as I go through to the focus. Okay, I didn't finish saying that, but this is one. This is point negative 3/4, right? If I go down. Maybe I should just start graphing this a little bit better. So I'm going to graph it right here. So I'm going to graph this. I got 1, I got 1, 1, 2, 3, 4, 1, 2. So I got my graph on there. I'm looking at my vertex, right, at 0, 0. Okay, because they told us this is where it's going to be. My focal length is -3/4. It's a directed focal length. It's right there. That's -3/4. That's my P. Okay, that tells me where my focus is going to be. I also know that my parabola is going to curve around my focus. Okay, the focal length, if the opposite of the focal length, tells me where the directrix is. Now remember, the directrix is, in this case, a horizontal line. Y equals opposite of P. Well, in this case, it's Y equal 3/4. So I got a directrix going across here. And I want you to actually get in the habit of putting the directrix in as a dotted line. Okay? So I've got my directrix in. The directrix and the focal length from the vertex is the same. So this is 3/4 as well. But it's just the opposite of P. Now, vertex is the center between the focus and the directrix. My next thing, my focal width. My focal width is the absolute value of 4P. We already got that. It's 3. What's half of 3? Yeah.
So is it 3 because you can't have a -3 absolute value?
Correct. It's 3 because of that. But we're also looking at a distance, okay, because we're looking at the length of that focal width. Yeah, and that way it's the same. And now I'm going to cut that in half. So half of 3 is 1.5. And what that means is across my focus, I'm going to go 1.5 and 1.5. These points are the end points of the chord that goes through the focus. That's the focal length. And my parabola goes through them from my vertex. Okay, so I've just graphed my parabola based on focal width, focal length, P. P is a big deal here. And do you notice where I put my directrix when I did it? And they asked me to find the focus. Well, my focus is at 0, -3/4. Okay, my focus is at 0, -3/4, because that's at 0P. When I look up, my focus is at 0P when it opens up and down. Okay. The next thing, the directrix, we got that covered. The focal width, we got that covered, and we even kind of graphed our parabola. Okay. Are you okay with what I did? We're going to step through another one together, and then you guys will do the last one. Okay. Read what we got. Okay. I got to find directrix, focus, focal width, and vertex. Okay. Vertex wasn't hard on this because all of them are going to be 0, 0, right? So that one's going to be pretty easy. When I go through this one, as I go through stuff, think about what's going. But the first thing we got to make a determination on, is it open up, down, left, or right? Because that'll tell me which side I'm using. I know it starts at 0, 0, but it can open anywhere from there, right? I got 4 choices right now. So find the equation in standard form for the parabola whose directrix is line x equal 2. So I've got a directrix, line x equals 2. So since I know x is equal to 2, I now know that since it's 2, my P really is -2. Are you okay with that? According to the fact that my directrix has to be the opposite of P. So if I'm sitting across here, I got a directrix at x equal 2, and I've got x equal to 1, 2. I've got this line coming through here. Okay, my directrix is x equal 2. Remember, the directrix is the end from my vertex, so my P is 2, we just found that out, but my direction from the vertex to P is over here, so my focus is right here. So I got my focus, maybe This is my focus. I'm just going to put it in. Okay, this is directrix. Open left or right now? Did you notice that it's got to be open left or right? So which way is it going to go since I got the focus where it's at? Right. Careful. Yeah, it's left. Okay, because keep in mind, this is the bottom of the, if you want to think of the bottom of the curve, okay, and this is the center of the curve. This is the buoy it's going to turn around, okay, if you want to think about it that way, okay. Now, focus is at point -2, 0, and they tell us that, so I know the vertex is 0, halfway between these 2 points, okay. Focus is on the axis. This is perpendicular to the directrix all the time, so it kind of tells me where this is located. Now, I already have P, so if I go for the focal width here, my focal width is my next thing. Oh, I haven't, my focus is -2, 0. We got to do that. I already answered that and I haven't filled it in. But my focal width now, since I already know P, the absolute value of this, I pop in P, that's -2, well, 4 times -2, absolute value is 8. So now, 4 on either side of my focus, 1, 2, 3, 4, and 1, 2, 3, 4, are the endpoints of the chord that is the focal width that my parabola will curve around. Okay, as we get that going. And I was asked to sketch the given info first. Okay, I kind of put that in. I labeled everything down. My last thing, I've got to write the equation in standard form. Okay, since it's open left or right, it's the y squared. Y squared equal 4p x variety. Okay, open left or right. And here's how I remember that. Open up or down is y equals x squared, right? So if it's not y equals x squared, it's open left or right, all right? So now I've got that set. I know it's going to go left, so now I know my p is negative, okay, for sure. And I even found p, it's right there. It is negative. So my last thing is to write my standard form of the equation. In the standard form, of my equation, remember, y squared equals 4, my p was -2x, so y squared equals -8x. And we're done. Much longer than you guys doing this next one. Okay, flip the page, last one, we're done with notes. I'm going to leave the hints up there for you and see where you're going to go. Okay, refer back to the table of the previous page. The table of the translated version of the parabola is below, so go back to the previous page to help you with the other stuff. Remember, it's all about P, and our vertex is 0, 0 automatically because everything's 0, 0 here. And I'm just letting you know that right off the bat. That the vertex halfway between the focus and the directrix. Just because it's y squared equals positive 12x, it's going to open right. Okay? It's going to open right. I know that the general form is y squared equal 4px. So 4p is equal to 12, which translates to p is 3. That tells me how far my focus is from the vertex. And a positive answer of 3 says it's 3 units to the right of the vertex. So I've got my focus here. I'm not sure why I did that, but well, that's my focal length I've got sitting in there. For some reason I didn't get rid of those. My directrix is negative 3 units back. Remember, the vertex is the center of the distance from my focus and directrix. So once I know P, I got stuff on either side of that. And because it's opening right, my directrix is right here. Okay? And my focal, do I have that down there? My focal width is 12 because that's 4P. It's the absolute value of 4P, but since P is 3, it's just 12. And I've got 6 on either side of my 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So I've got that going and that going as I get that sketched. Okay? Make sure you include your directrix in your sketches. Okay? Make sure you put that dotted line that in there. I want to make sure that's there every time we make a graph of this. Are there any questions about how I did stuff or what I did when I did it? I just left this open. I should have left. I did that up on top. Are you okay? Yeah.
Could you explain the reasoning again behind finding the vertex? Like knowing that
The vertex itself is the midpoint between the focus and your directrix. And it is the midpoint of the axis of symmetry of your parabola. Okay? Does that make sense? Because it's always the midpoint, but specifically our vertex, because this distance is the same, but this distance and back here is also the same. Okay? So you always got to keep in mind that this is the shortest distance to the directrix is through the vertex from the focus. Okay? And you'll notice that most dishes stop here. Okay? And they're used to like either reflect light or receive information. Okay? As we're going through. Any other follow-up questions? I'm telling you, the more often you do the problems, you know, if you get to them right now, matter of fact, I think you can almost finish this assignment. It goes pretty quick. Make sure when you're graphing, you include your directrix, okay, and get it going. I've got graph paper in back if you need it, or you can just draw it on your page like I did when I did them, okay? The assignments are up, and we'll get that going.